Now we do question B to get Z in and Z out. So we refer to the AC equivalent circuit for this source follower. Okay, I do step by step to get the final circuit. Okay, please take note the current flow at GM-VGS. The GM-VGS flow from D to S. D to S. So when I transform into another this one, the circuit 2. This is a circuit 1. This is circuit 2. See? Now, because this is the source follower, so the drain become at ground. Okay, we switch this D to S. Okay, we bring this D to S because now D is connected with this ground. So when I bring this D into ground, okay, automatically this direction of the GM-VGS become opposite like the previous at the side figure. The left side figure is from top to down here like this. Okay, because the current must flow from D to S. Okay, then here the V out is at S. Okay, so this is the V out here and is at S. Okay, so I get this circuit for the source follower. Then we find the Z in. The Z in is very straightforward. You can get Z in equal to Rg 10 mega ohm. Okay. However, for the Z out, it's quite complex. However, I want to show you two methods that you can use to get Z out. The first method is very easy method. By referring to this figure, okay, take a look at this part. Okay, at this part where we have actually GM-VGS is the current, and then here to get and we can see that the RS now parallel with RD. Only this GM-VGS is in I current. So we change this current into R. So how we going to use it? So we know that R is equal V divided by I. So I for this equation now is GM VGS. So the V voltage across this GM VGS is VGS. Okay, VGS. If we can see at the left side figure here, this VGS is parallel with the GM VGS, the current. So we can say that our voltage here is VGS. So you get resistor at this part equal to 1 over GM. So now this circuit is become like this. If I can visualize, so this is the RD, this is the small RD, and this is 1 over GM. Okay, the R value. So you get this equation. Alright, the second method using KCL. This method is quite long, but it can prove the answer is same with the first method. So I will show you step by step. Take a look at this figure, okay, where we have all direction for the current and so on. So we know that Z out equal to V out divided by I out. So we find I out at node S using KCL. Node S is here. So you have current flow from here and here and here. Okay, so the KCL is here. First is GMVGS plus with IRD minus with IRS plus I out equal to 0. Then rearrange this equation because I want to get I out. Okay, I get this. Okay, now we expand the equation for IRS equal to V out over RS. Take a look here. Voltage drop across the RS is same with the V out here. Okay, same goes to the VRD, V out, but I put negative here because the polarity of the current is different. Okay, positive, negative here. The I is come from negative to positive. Okay, so that's why I use negative, negative. Then we go to negative GM multiply with negative V out. So this VGS, negative VGS is equal to negative V out. Sorry, V out equal to negative VGS. It different polarity here. But the voltage is same in parallel. Okay, we get this. And we solve it until we get I out and V out. So insert this equation, the I out, into this equation. Okay, we know that we have V out over I out, so we just maintain this V out and then insert the equation that we derive. We get I out here, and then we remove the V out, cancel it with each other's V out and V out, and finally we get this equation 1 over 1 over RS, 1 over RD, and plus GM. So these three are parallel resistor. So for the GM, we turn into this, to make it become the parallel. Easier. So this is the final equation. You can see, we check Z out equal to RS parallel with RD and parallel with 1 over GM. So we compare it like this. Yes, equation is same. So you can choose any method that you think that one is easy. Okay, so here I just give some explanation about the current, the IRD, V out here. You can check at the handout. I will give you later this handout. Then we insert the value in the equation, the RS, RD, 1 over GM. So we get final answer is Z out equal to 507.6 ohm.